Welcome to you all once again to my channel. So today we are going to discuss about measurement of power. Now, being an electrical engineer or instrumentation engineer, it is basically needless to mention the necessity of power measurement, because everywhere, every electrical appliances, when we are going to use them, we need to take care about its power that it consumes or it draws from the system. So just going into the topic, that is measurement of power. So already we know that power, normally represented by P, is given by equation V into I, where V and I are the voltage and current respectively. So what it actually means? It means whenever an electrical appliances draws a current of I and the potential given across it is V, then their multiplication gives us the amount of power it draws from the system. So power can be represented by another equation, that is Vi cos phi. So now the question is, what is the actual equation, whether it should be V into I or Vi into cos phi? The answer is that both the equations are absolutely correct. So when we are talking about P is equal to V into I, we are basically considering DC system, and when we want to measure power for an AC system, then the equation becomes V into I into cos phi. Now, when we are talking about AC systems, to realize an AC system, we prefer to describe it with the sinusoidal signals. So here in the diagram we can find I have drawn three different curves. The first one, the blue line, represents the current, the AC current, that is basically a sinusoidal curve you can find. Similarly, the voltage due to which the I current is flowing through it is basically V, so that one is the black line, and their multiplication gives us the power, that is the green line, which is basically P. So here we can find in the negative half cycle, when current and voltage both are negative, but their multiplications should be a positive value. That means during the negative half cycle, when current and voltage both are negative, but still the appliances or that particular instrument draws power from the system. So that is why power is always positive, even if we are considering AC, because we might think that in AC system we should have a positive half cycle, should have a negative half cycle, but when we are considering power, then all the half cycles should be a positive one. And second thing is that in this diagram I have represented V and I in absolutely in phase. So that represent that the phase difference between V and I is 0. So probably we can say this diagram is applicable for the load which is pure resistive in nature. So we can draw this different kind of diagram for inductive load and capacitive load also. And in those particular cases, the diagram of P will be something different and interesting one. So we will go into that in the latter part of the video if it is possible. So now the target is that in case of power for an AC system, we write down P is equal to V into I into cos phi. Now from where the cos phi concept came? We already know that cos phi is basically the power factor. So what is the meaning of this power factor? Power factor defines a particular value. Normally the upper limit is less than 1. And this particular topic came into picture due to the phase difference between the voltage and current. That current which is drawn by the system when V is the amount of potential applied across that particular system. So in case of AC system, how to measure power? So for that we have tried to calculate the equations. It's a very easy one, but you need to remember it. So for AC power calculation, what we can write down, we need to take the instantaneous value of current and voltage. What does it mean? So if we go into this diagram once again, we can find that for every possible values of T, we have individual different values of I as well as individual values of V. That instantaneous value, the multiplication of these two instantaneous current and voltage should give us the instantaneous value of P. So we can find that as the signal changes its amplitude, the instantaneous value of current and voltage as well as the power changes. So that is why I have taken instantaneous current I is equal to Im sin omega t, that flows through a system only when the instantaneous voltage applied across it, that is small v, is equal to Vm sine omega t minus phi. Here phi is the phase difference between this current and voltage. So phi is the phase difference. Phi is phase difference. So instantaneous power small p should be equal to the multiplication of this v into I. So right now we will try to put this value. So v and I is equal to Vm sine omega t minus phi into Im sine omega t, or we can write down in this way: Vm into Im into sine omega t minus phi sine omega t, or we can write it down in this way: Vm into Im divided by 2, then it becomes 2 into sine A into sine B, 2 into sine A into sine B. That will give us cos A minus B, A minus B cos A minus B, that is minus phi, and minus of cos 2 omega t minus phi. Now cos minus theta is equal to theta, so that does not make any difference, so that does not make any change. So we can write it down in this way: Vm into Im divided by 2 is equal into cos phi minus cos of 2 theta minus phi. So what is theta? We have taken theta is equal to omega t is equal to theta. We have assumed that one. Okay, so that is the instantaneous power. Now how to find out the total power delivered to the system or consumed by the system during this period? So for that we need to add all the instantaneous values of power starting from this location up to this location. I am repeating it once again. So if I need to find out the value of power drawn by the system throughout this particular cycle, then we need to add all the individual instantaneous values of power starting from 0 up to t. So in terms of angle, we can say this here the angle is 0 and here the angle is 2 pi. So the average power, can I see it? Yeah. So the average power drawn by the system for this cycle, we can write down capital P is equal to 1 by t integration 0 to t, the time period of instantaneous power, into time domain dt. So now putting the value of P, I can write down here the time period t is equal to basically 0 to 2 pi. So the time period is 2 pi, limit will be 0 to 2 pi. The value of P is Vm into Im divided by 2 cos phi minus cos of 2 theta minus phi into d theta. So here the integration will be done with respect to theta. We have changed that one. Okay. So I can write down 1 by 4 pi into Vm into Im integrating 0 to 2 pi cos phi d theta minus integration 0 to 2 pi cos 2 theta minus phi into d theta. So that is Vm into Im divided by 4 pi. The integration value of this one, this is the constant value, so it will come here as cos phi. The value will be theta. Theta should has a limit from 0 to 2 pi. We need to put it here, minus, this is cos A minus B, so we need to break it down, cos A minus B, that is integration 0 to 2 pi cos A cos B, cos A cos B minus sin A sin B into d theta. So that will give us here, Vm into Im by 4 pi into 2 pi into cos phi from this term, minus Vm Im by 4 pi. I am doing the multiplication. Here I need to do the integration of this term. So here cos phi is once again constant term. Integration of cos 2 theta is sin 2 theta divided by 2 the limit is 0 to 2 pi minus integration of sin 2 theta will be minus cos theta. So I am writing here Vm into Im divided by 4 pi, minus it will get into plus, so it will be cos 2 theta by 2 into sin phi when theta changes from 0 to 2 pi. So we have done the integration. So we can find out that sin 2 theta by 2, if we put the value of 2 pi here, then it will be sin 2 pi minus sin 0. The value, let me explain it here in the next line. This is Vm Im by 4 pi into 2 pi cos phi minus take common Vm Im 4 pi. So this is cos phi multiplied with sin 2 pi minus sin 0 plus sin phi into cos 2 pi minus cos 0. So sin 2 pi is 0, sin 0 value is 0, cos 2 pi is 1, cos 0 is 1. So all this term will be cancelled out because it gives me the value as 0. So the final value that we are getting here is basically this one, Vm into Im divided by 2 into cos phi is equal to Vm by root 2 into Im by root 2 into cos phi. Now Vm by root 2, Im by root 2 is basically their RMS value. So this is Vrms multiplied by I of RMS into cos phi. That is what we write down normally as Vi cos phi. So this is the equation, and that is how it came into picture. So basically what we have done, that wherever it is a AC system or DC system, power is basically V into I. If we put their equations and after doing all this calculation, I will get V into I into cos phi. We need to remember here the V and I that we are talking about here is basically their RMS values, and we need to remember by using all the ammeters and voltmeters, whatever current and voltage you basically measure is basically their RMS values. So the RMS values, multiplication of the RMS values multiplied by cos phi gives us the power in AC system, where phi represents the phase difference between voltage and current, and cos phi is called power factor. Thank you.